Today we're going to get into a little bit more of the sine and cosine of complementary angles. We have seen this chart before in our previous note sheet in the class. We're going to fill this out again. Hopefully this is going to make sense. We're looking at angle A. Sine of angle A, we know sine is opposite over hypotenuse. Cosine of angle A, we know is the adjacent side over the hypotenuse. And tangent is going to be our opposite over adjacent. And now that was all with regards to angle A. Switching it up now to angle B, we're going to see the ratios change. So the sine of angle B, sine again is opposite over hypotenuse. Notice your opposites change. Okay, cosine of angle B is adjacent over hypotenuse. And then your tangent is opposite over adjacent. And the pattern that we've seen before, the pattern that hopefully we're seeing here again, is that when I look at the sine of an angle, sine of angle A, it's going to be the same thing as the cosine of B. Or vice versa, I could say the sine of angle B is equal to the cosine of angle A. So looking at this, we said the acute angles in any right triangle. So I'm looking at perhaps angle A and angle B. Those two acute angles will always be complementary, meaning they're going to add to equal 90 degrees. So to put this all together, we can then say the sine of any acute angle, so for instance the sine of angle A, is equal to the cosine of its complement. Okay, so taking a look at the rules, what we can take a look at. So if A and B equal 90, so that's basically saying my two acute angles are complementary. So this is kind of like going with that first thing that we had here. Then we can say, well, that's going to be true if and only if, as long as I know the sine of angle A is equal to the cosine of angle B, or the sine of an angle is equal to the cosine of its complement. Okay, so we're going to use those two equations, and we're going to try and rewrite this, but in terms of one angle, because we always say if we have two variables, we need two equations to solve. So considering these two formulas that we have, let's start with that A plus B equals 90. And maybe I want to get A by itself, so I need to subtract B to each side. So what that shows me then is A is equal to 90 minus B. Okay, so if I go back into this equation, rather than writing sine of A, I'm going to substitute in place of A what I know it's equal to, 90 minus B. So now what we just did is we wrote one equation in terms of the other. Okay, using that whole idea that if those two angles add to equal 90, that's because the sine of the angle is equal to the cosine of its complement, and vice versa. Okay, so how do we use this to solve for angles? Well, if I take a look at angle A, keep in mind what I have here. The sine of an angle is equal to the cosine of its complement. The only way that that happens is if I know that A plus B, keep in mind that's like your A, that's your B, so theta plus 32 equal 90. Okay, so if I want to solve for theta, I could subtract 32 from each side, and I'm going to see theta is 58. Now, if I wanted to check this and make sure that this made sense, I could plug it back in. So it's saying the sine of 58 should equal the cosine of 32, and that's only true so long as 58 plus 32 equal 90, which they do. If I add them up, I'm going to see that that's 90 degrees. Okay, trying another one. So we have the cosine of theta is equal to the sine of theta plus 20. Well, the sine of an angle is equal to the cosine of its complement, meaning if I added them up, they should be complementary, they should equal 90. Okay, so if we gather like terms, I have two thetas, and I'm trying to get theta by itself, so I'm going to subtract 20 from each side, and we have 2 theta is equal to 70, so that means if I divide by 2, theta is equal to 35. Okay, We have another one. So we have sine of theta is equal to cosine of 3 theta plus 20. Okay, so again, this is only true so long as the two angles, when they are added, will equal 90. They have to be complementary. Okay, so if we combine our like terms, that gives me 4 theta plus 20 is equal to 90. Subtract over the 20, so now I have 4 theta is equal to 70. And divide by 4 to get theta by itself, and theta is going to equal 17.5. And if you don't like theta, if that freaks you out for right now because we're not used to it, make it an x. It's a variable. That's all it is. Okay, and our last example, so now we have a fraction. So no big deal. Works the same way. So I know that these two angles, when I add them up, should equal 90. So I have 1 theta and 1/3 theta. That's a different way I could write that. I could do the same thing and do 1/3 theta. That's going to give me a total of 4/3 theta plus 10 equals 90. So first we subtract over the 10. So now I have 4/3 theta is equal to 80. And to get theta by itself, I can think multiply by the reciprocal. And I have to do that on each side. So when you multiply by the reciprocal, I'm going to be left here with theta. That's what we want. And on this side, think when you multiply fractions, tops with tops, bottoms with bottoms. And when we simplify that down, it's going to leave you with theta being 60. Okay. Similar type question. On the back, it says in a right triangle ABC with the right angle at C, we know right now the sine of A is equal to 2x plus 0.1. And we know the cosine of B is equal to 4x minus 0.7. We have to figure out the value of x. Okay, so we know we've had this equation, we've written this down a bazillion times. Sine of A is equal to the cosine of B. Okay, so let's do a substitution. Instead of saying sine of A, we're going to replace what it's equal with. 2x plus 1.1. And cosine of B, we're going to replace that. 4x minus 0.7. And now we can solve. So first I'm going to move our x's, get our x's onto one side. So 0.1 is equal to 2x minus 0.7. Add the 0.7 to each side, so I have 2x is equal to 0.8. And if I'm trying to get x by itself, divide through by 2, so we have 0.8 divided by 2. That's going to leave us with x equaling 0.4. And how does this relate back to the right triangle? Well, we know the sine of an angle is equal to the cosine of its complement, so what does that mean? That means A and B are complementary angles. And if I plug that in, I could at some point in the next unit, we're going to figure out how to solve for that angle. Okay. Change the pace just a little bit. We're going to learn how to work with our calculators and actually see how do I start to solve for some of this. So the one thing that you want to make sure of is that we have to be in degree mode. I'm going to show you on your calculators. You want to check that out. For the most part, we are going to be doing everything in degree mode. We'll do a little bit in what's called radian mode a little bit later. And next year in Algebra 2, you're going to do the same thing. So if you're trying to switch it to degree mode, just remember you have to make sure it's in degree mode. You're going to press mode and highlight degree. It says we're going to type in the trig function that we're using and then press enter. And it says round the decimal places to the nearest 10,000th. This is 4 places. Pretty standard rounding, I would say, for trig. So using our calculator, I have the sine of 70. So I'm going to go to my trig button, which is right next to 7, and I'm going to take the sine button. Notice I have 2 different signs. I want regular plain old sine, and it opens up a parenthesis. That's looking for the degree, and I'm going to plug in 70. And notice in the upper right-hand corner it says DEG. That's how you want to make sure it's in degrees. I press enter, and it wants it to the nearest 10,000, 4 decimal places. So I have 0.93969. We go to that 9. We look up for rounding, so I would get 0.9397. So 0.9397. We're going to do the same thing with cosine. So again, go back to the trig button. I'm going to take my cosine, and it says of 70 degrees. So type in 70, press enter. It's at 0.34202, so with rounding, 0.3420. There's my nearest 10,000. And our last one is tangent of 70. Okay, so again, trig button. Notice I'm taking just the regular tangent again, and we're going to do tangent of 70. Press enter. Again, 4 decimal places, so 2.74748. That 0.8, it's 5 or above, we give it a shove. So 0.7475. 2.7475. And that's all you have to do. That's just a plug and chug, evaluate it on the calculator. Okay. Connecting it to triangles. So now we're going to put our ratios together and solve. Okay, so this is a right triangle. The marking is missing. We have to solve for x. So I know x is the hypotenuse. According to 42, I know 5 is opposite. So what that means is we'd be using our sine ratio. And keep in mind what we have. It's always sine of your angle, this time we have a number, is equal to opposite over hypotenuse. Now we have to solve for x. So when you solve this, then put the sine of 42 over 1 and cross multiply. So we have x times sine of 42 equals 5. And we want to get x by itself. So I'm going to divide through by sine of 42 on each side. Okay, so now we're going to go back to our calculator and we're going to do 5. First, we're going to get a fraction. So control, divide, we get a fraction. 5 divided by, we need our trig button, so we're going to do sine 42. And I'm going to press enter. And it says again, nearest tenth, so only one spot this time. So we get 7.47, so I look at the 7 to round up, so I get really an answer here of 7.5. Okay, and our last one. So we have, again, starting labeling your triangle, 12 is the hypotenuse, x is the side opposite. So again, we're going to use sine. Okay, and we start off and we say sine of the angle, sine of 35, is equal to opposite over hypotenuse. So again, we put that over 1 and cross multiply, so that gets us 12 times sine of 35 is equal to x. Okay, so we're going to grab our calculator and type that in. So we have 12 times sine 35, and we press enter. Nearest tenth, so this gives me 6.88, so that 8 bumps it up. I get 6.9 for a final answer. So I can tell you here, x is equal to 6.9. So we just found the side length of your triangle. We're going to do more of this in class. Don't forget to like and subscribe. The other thing is, if you're sitting there saying, I can't do this, you can. Take your cell phones, your iPhones at least, if you turn it horizontally, will bring up the trig buttons, and you're going to see sine, cosine, and tangent. That's a way to do your homework at home. However, when you enter in those buttons, it's actually going to be backwards. So you have to type in, for instance, if you were to do sine of 42 on your phone, you'd have to type in 42, and then the sine button, then enter to get a value. We will practice that more in class. Have a great day.